Question 5, Tracy wants to make a cylindrical model. The height of the cylindrical model, h of v in inches, is modeled by the equation where v is the volume of the cylindrical model in cubic inches. So h of v equals 2.69 times the cube root of v. What is the average rate of change of the model's height when its volume changes from 512 to 1,000 cubic inches? So first off, they want average rate of change. Recall, average rate of change is fancy for slope. And the slope formula is y2 minus y1 divided by x2 minus x1. So obviously in this problem, they have to give us some of these values. So 512 and 1,000. Those are the input values because those are the volume, and volume is our input variable. It's the independent variable in this problem. Volume is in the spot where x normally is. So our x values are very easy. They're given to us. 512 and 1,000. In fact, using this slope formula, we can go ahead and set it up. y2 minus y1 divided by, let's just call 1,000 my x2 divided by 1,000 minus my x1 of 512. To find the y values, a little bit more work to do, but not much more. To find the y values, we're going to take the x values or the v values and substitute them in for our input variable and figure out the output. So let's first type in this equation 2.69. Use any calculator, but if you're using a graph calculator, to find the cube root button, you're going to press math, and for me it's number 4. And we're going to take the cube root of 512. We get 21.52. And now we're going to take 1,000 and input it for the v variable. So same process, except instead of 512, we want 1,000 underneath, and we get 26.9. It's important to note, if 1,000 is my x2, that means 26.9 is my y2. You just as easily could have said 512 was the x2. It doesn't matter, but you have to be consistent. So 1,000 is my x2, it means 26.9 is my y2. 512 is my x1, 21.52 is my y1. So we're going to replace (26.9) minus 21.52, and then let's let the calculator do the rest. 26.9 minus 21.52. There's my numerator. Denominator, you can probably do that in your head, but let's just make sure we don't make a mistake. 488. So it's our numerator, 5.38, divided by our denominator, 488. And our rate of change should be 0.011. And that is indeed what it is.